Hey everybody, I'm Giles Lavelle and this is Python from Scratch, a video series for NetTuts where we're learning the Python programming language. This is the fourth episode in the series, and today we're learning about Object-Oriented Programming, or OOP. So this is slightly more complex than anything we've covered so far, so if you're new to Python I recommend you go back and check out the previous 3 episodes, which are all available right here on NetTuts. But if you already know a bit of Python and you think object-oriented programming is the next level for you, then we're ready to start the lesson. So Python is primarily an object-oriented language, but what does object-oriented actually mean? There are a lot of different ways you can define the term, and you really could talk for hours trying to explain the complicated ins and outs, nuances, and differences in implementations, but I'll try to give a quick overview. Broadly, object-oriented programming can be thought of as a concept that when you're programming, the objects that you're manipulating are more important than the logic needed to manipulate those objects. Traditionally, a program has been seen as a recipe, a set of instructions that you follow from start to finish in order to complete a task. That can still be true, and for many simple programs that's all that's required. That approach is sometimes known as procedural programming. When we talk about object-oriented approaches, what we do is put the object at the center of the process, instead of simply using them as necessary containers for the information as part of the procedural instructions. The first thing we do is define the objects we want to manipulate and how they relate to each other, and then only once we've done that do we start to flesh it out with the logic to make the program actually work. So when I talk about objects, I can be talking about all sorts of things. An object can represent a person, which would have properties such as a name, age, and address. It could represent a company, which would have properties like the number of employees and so on. Or it could even be something much more abstract, like a button in a computer interface. In this introduction, we're not going to cover all of the concepts in this topic, because we'd be here a long time, but by the end of the tutorial I hope you'll have a good basis for the principles you need to start straight away using some simple object-oriented techniques in your Python programs. And also in many other languages, because these concepts are fairly similar in a lot of programming environments. Okay, so let's go ahead and open a new Python project in our favorite editor or IDE. I'm just going to save this file out before we start, so whether you're using a text editor or IDE you should do this. I'm just going to call it lesson 4 and make sure it's a Python document so we get some syntax highlighting. There we go, we're ready to start. So I mentioned that the first thing we should do when we're going for an OOP approach is to define the objects we're going to be using. The way we do this is to define the properties that it possesses using something called a class. You can think of a class as a sort of template or blueprint, a guide for the way an object should be structured. Each object belongs to a class and inherits the properties of that class, but acts individually to other objects of the class. An object is sometimes known as an instance of a class. As a simple example, you might have a class named person with, say, an age and a name property, and an instance of that class, an object, would be one person. That person might have a name of Andy with an age of 23, but you could simultaneously have another person belonging to the same class with a name of Lucy and an age of 18. It's hard to understand this without seeing it in practice, so let's get some actual code going. To define a class, in Python's typically simple way, you simply use the word class followed by the name you want to give it. I'm going to make a new class here called pet. So I will type class and then give it a name. Kind of like defining a function, we use a colon after the name, and then anything contained within the class definition is indented. So I will indent right there. So now we've got a class, but it's pretty useless without anything in it. To start off with, let's give it a couple of properties. To do this, you can simply define some variables inside the class, and I'm going to go with number of legs to start with. As usual, you should always name your variables so that it's easy to tell what they are, so let's call it number of legs here. We'll need to define a value or we'll get an error, so I'll use 0. So let's say number of legs equals 0. In this case, it doesn't matter too much which number you choose, because the number of legs will be specific to each instance of the class. For example, a fish doesn't have the same amount of legs as a dog or a duck, so we'll have to change that value for each object anyway. There's just one thing here I want to pick up on very quickly. It's not related to object-oriented programming, but it's something worth knowing about. In previous lessons, I've been using camel case for my variable and function names, which is where you use each word in the variable name, the first letter of it is capitalized, and then there's no spaces. So I would previously have written it number of legs. But that's not the Python convention. The Python convention is to separate each word with an underscore and then have everything in lowercase. So this isn't a massive issue. Your code that you've learnt in the previous lessons will still run, and it's not essential, but it's good practice when you're learning to get things right from the start. So I'm sorry if that's caused any confusion, and from now on we're going to be using this naming convention. Okay, so I just wanted to mention that very briefly. Let's carry on now. Right, so I could add more things to this class, such as age, length, and so on, and obviously in an actual program you certainly would. But for this first example, let's keep it as simple as we can. Let's have a look at how you would use this class. A class on its own isn't something you can directly manipulate, so first we have to create an instance of the class to play with. We can store that instance in a variable. Outside of the class, so without any indentation, let's make an instance of the class and store it in a variable, give it the name of our pet. I'll call it Doug. To make a new instance of this class, you simply type the name and then a pair of parentheses. At this point there's no need to worry about the parentheses, but later on you'll see that they're there because, like a function, there's a way of passing in a variable for use by the class when you first create the instance. So we'll say Doug is a pet. So now we have an instance of a class. How do we access and manipulate its properties? Well, to reference a property of an object, first we have to tell Python which object, or instance of a class, we're talking about. So we're going to start with the one we just created. Then we're going to put a dot, so we will say Doug, dot, and then this indicates that we're referencing something that's contained within this instance. After the dot, you add the name of the variable, so for accessing the number of legs variable, we put that after the dot. So Doug dot number of legs. And this now is like a regular variable and it has the value of 0. Here I'm going to assume Doug is a dog, and I'm going to give the variable the value of 4 to show that he has 4 legs. To access that variable, we use it again exactly as we would treat any other variable, but using Doug dot before the name instead of just the normal variable name. So let's put a line to print out how many legs Doug has, so that we can show that it's working like it should. So let's print Doug has, and we will use the string interpolation operator to pass in this value. Doug has a certain number of legs. And then we will pass in Doug dot number of legs. And that should print out Doug has 4 legs if it works. So let's run the code. I'm going to switch to the terminal and navigate to my documents directory and then simply run the script with Python. And you can see we get Doug has 4 legs. Now that's a simple result, but it's come from an object-oriented approach. So you can see just how simple it is to get started with object-oriented programming. What's happened here is that we've defined the pet class, created a new instance and stored it in a variable. Then we have set the value of a property of that instance and then retrieved that value in a print statement. So you can see from that very simplified example how you can begin to build nice modular data structures that are clear and easy to use and can also scale quite nicely as your program grows. Okay, so that's the very basics of classes and objects, but at the moment we can only use them as data structures, containers for variables. That's all well and good, but if we want to start doing some more complex things with the data we're manipulating, we need a way of introducing some logic into these objects, and the way we do that is with methods. Methods, essentially, are functions contained within a class. You define one exactly the same as you would a function. The only difference is you have to write it inside a class, and that means it belongs to that class. Then, if you ever want to call the method, you have to reference an object of that class first, just like the variables we were just looking at. So I'm going to write a quick example here into our pet class. Let's just remove the code from our last example that we don't need anymore. So we'll just get rid of that for now. Okay, so I'm going to create a method called sleep, and it's just going to print out a message when it gets called. So first, like a function, we write define, then the name of our method, then we put parentheses, and then a colon, and then anything that's part of the method is indented. Now, there is another difference between a method and a function, and that is that a method always has to have an argument called self between the parentheses. When Python calls a method, what it does is it passes the current object to that method as the first argument. In other words, when we call Doug.sleep, what's going on is Python is going to pass the object Doug as an argument for the sleep method. We'll see why that is later, but for now you need to know that with a method, you always have to include an argument called self first in the list. And if you want to add more arguments, you can add them afterwards, exactly like if you were passing multiple arguments to a function. If you don't include that argument, when you run the code, we're going to get an error thrown because Python is passing in an argument, which is this self object, and the method is saying that it doesn't take any arguments. So it's the same as if you tried to pass an argument to a function that doesn't take any at all. So let's add self to the method definition. So inside this method, let's just put a very simple print statement to test if it works, and we will just put the classic sleep sound effect. There we go. So now, if we want to use this method, we can use an instance of the pet class to reference it. Just like the number of legs variable, we write the name of the instance, so we've already got one called Doug, then a dot, and then the name of the method, and then our parentheses. Note that we're calling sleep with no arguments, but Python is going to add in that argument by itself, so we're going to get the right amount in total. Okay, so let's run this code now. And as you can see, it's printed out the message, which means we've successfully called our first method. So what's happened here is that a new instance of the pet class has been created, we've then referenced the sleep method within that object, and it's printed out the message that we wrote. Okay, great. So how about we write a new method to print out how many legs the pet has, to demonstrate how you can use methods to start manipulating the data within the class, and to demonstrate why we need this confusing self argument. So let's make a new method called countLegs. We will define a countLegs method, parentheses with the self argument, and then indent. So your first instinct may be to do something like this. Print out I have a certain number of legs. And then you may want to pass in the number of legs variable. Then we would go on to set the number of legs equal to 4, and then finally we would call the countLegs method. So let's see if that works. Okay, it doesn't, and we've got an error here saying that number of legs is not defined. So why is that? Let's go back and take a look. The reason for that is that the method can't find the variable, so it can't print its contents. Now you might be thinking, well, the variable's right there, why can't it find it? But remember when we were accessing number of legs from outside the class and we had to use Doug.number of legs instead of just number of legs? The same principle applies. If we want to know what's contained within that variable, we have to reference it using Doug.number of legs. So let's edit our code and add our object in. Okay, and we will run that. Okay, so you can see that that worked, but there's now a very big flaw in this class, and I'll demonstrate that now. If we create a new pet, we'll say Nemo, and this can be a fish. Then let's set, obviously, a fish with 0 legs, and then we call countLegs, and then we go and run that. You can probably see what's going to happen. We're going to get 4 twice, and that's because we're directly referencing the number of legs Doug has here. So we have this problem that in the class we know the part of the object we want to manipulate, the number of legs variable, but we don't know in advance the name of the object, so we can't reference it in the code. So now this is where the self object we were talking about earlier comes in. What we can do in this example is replace Doug.number of legs with self.number of legs. And if you remember, I mentioned that self was a reference to the current object, or the instance of the class that we're working with at the moment. So if we replace this with self, this time Doug will be passed in to there, and then this time Nemo will be passed in instead. In practice, this means that wherever you write self in your method, when you run the method, self is replaced by the name of the object. If you think about it, this means that our method will run exactly as intended, because the self reference will dynamically change depending on the context and allow us to manipulate the data only within the current object. So let's run this again and see if we fixed it. We get different messages each time. The main things to remember about methods is they're exactly like functions, except the first argument has to be self, and that to reference an internal variable, you have to preface the variable name with self. Just as a quick note, you could actually use any name instead of self for your methods. The methods here would work just as well if we renamed the variable to any other word, but using self is just a convention which makes it useful to Python programmers because it makes the code much more standard and easy to understand, even if it's written by someone else. So my advice would be to stick to the conventions, but if you want less to type, you could even just use S. If that last bit went over your head, don't worry too much about it. Just stick to self, because that's what we're going to do in this series. So, now that we've been over the basics, let's have a look at some of the more advanced features of classes, and how they can help make your programming easier to structure. The next thing we're going to talk about is inheritance. As its name suggests, inheritance is the process of making a new class based around a parent class, and allowing the new class to inherit all the features of the parent class. This new class can then obtain all the methods and variables from its parent class, which is often known as the base class. Let's extend our pet example to see how this might be useful. If we use pet as our parent class, we could create a child class which inherited from pet. The child class might be something like dog or fish, something that is still a pet but more specific than that. A dog is a pet and does the same things all pets do. For example, it eats and sleeps and has an age and a number of legs, but it does other things that are specific to being a dog, or at least more specific than to being a pet. Dogs have fur, but not all pets do. A dog might bark or fetch a stick, but not all pets would. Getting back to the point, say we wanted to make a class in our program to represent a dog, we could use inheritance to inherit the methods and variables contained within pets, so that our dog could have a number of legs and the ability to sleep, in addition to all the dog-specific things that we might want to store or do. Now you might be wondering why, if we want that, we don't just put those methods into the dog class and get rid of the pet class. Well, inheritance gives us two advantages. One, if we want an object that is a pet but isn't a dog, a generic pet if you will, we can still do that. Two, perhaps later we want to add a second type of pet, like a fish class for the Nemo object. We can make that second class also inherit from pet, so both classes can share everything in that pet, but at the same time have their own more specific methods and variables that apply only to that type of object. We're getting a little bogged down in theory and words here, so let's write something to make it a little clearer. First, let's delete everything except for the pet class, just to clean things up. So first we're going to write a new class called dog. But this time, between the class name and the colon, we're going to put some parentheses, and then in them we're going to write the name of the class that we'd like to inherit from, sort of as if we're passing in this new class as an argument, like we would a function. So our class of dog inherits from pet, and then we have our colon, and we can define all the dog methods and variables here. So let's give this class a simple method to show how it works. I'm just going to add a bark method that will print woof. So we will say define bark and print woof. So you wouldn't want that available to all pets because not all pets would do that, but you would want that available to dog. Dog is obtaining count legs and sleep, something that all pets should be able to do, so it now has 3 methods available to it. So let's see what happens if we make an instance of this class. I'm going to call it Doug again. And I'll just go back and add the self argument to the bark method. Missed that out there. Okay, so let's make an instance of this new class. So I'm going to call it Doug again, and we'll say it equals a dog. Then we will just call the bark method on it. And let's see if that works. There we go, we can see it's run just like we expected. That's great, but we haven't actually done anything new yet. We've just got a class with a method. What inheritance has done for us, though, is to make all of the pet functions and variables available to us through the Doug object too. So, if I do something like this and change it to one of the methods that's only in pet, if I change it to sleep, that should also work because it's inheriting. So if we change back, we can see that it's gaining all of the methods of the pet class. So our Doug object belongs to both the pet class and the dog class. Okay, just to finish off this example, we can demonstrate that variables get inherited the same way by using our countLegs method. So we've got our instance of the dog class, it's inherited the number of legs property and the countLegs method, which means we should be able to just set the number of legs to 4 and then call the countLegs method, and we will go and test that out right now, and you can see that it's gained access to both variables and methods of the pet class. So this new child class is just a specialized version of the parent one with some extra functionality but retaining all of the previous functionality. Okay, so that concludes our tour of the very basics of object-oriented programming in Python. There's a lot more to this field, but it can all get pretty complex very quickly. So because this is a series for beginners, this is where we're going to conclude today. In the next and final episode of the Python from Scratch series, we're going to be looking at Python web frameworks and how you can use all the skills you've learnt in this and the previous 3 lessons to finally create a simple dynamic website with Python. I hope you found this lesson informative, and as always, if you've got any questions about it, I'll be happy to answer them in the comments. And yeah, as usual, always go to net.tutsplus.com for the best programming tutorials on the web. I'm Giles Lavelle. Thanks very much for watching.